So today we will be looking at the word problems of the ideal gas equation. Okay, so the first word problem that we have is that laughing gas N2O at 30 degrees Celsius and 820 torr pressure occupies, okay, consider this is a cylinder, right? This is a cylinder and it contains N2O gas, which is the laughing gas, right? It contains that at 30 degrees Celsius. The temperature is T1, which is 30 degrees Celsius, right? And other we are having pressure, which is 820 torr. The pressure is P1 is 820 torr, and the volume here V1 is equal to 10.32 dm cube, right? And now in this equation they have said that we have to calculate the V2. We have to calculate from the data first, right? So coming at here, let's form data. According to data, our V1 is equal to 10.32 dm cube, right? And the temperature, the T1 is equal to 30 degrees Celsius. P1, which is pressure, is equal to 820 torr, right? And what else is giving? Yeah, this is giving. And now we have to basically find V2 at STP. STP stands for standard temperature and pressure. So it means that the T2 is equal to 273 Kelvin, which is the standard temperature, and the standard pressure is P2 is equal to 1 atm. So we can easily find the V2 by using the ideal gas equation. But before that, we have to convert these units in the STP, like in the standard unit. Like for example, here we are having 30 degrees Celsius, right? Now we have to convert this Celsius into Kelvin. So the formula for that is, like, if you want to convert Kelvin into if you want to convert Celsius into Kelvin, the formula is like, we have to plus Celsius plus 273, right? So here what we'll do, you have to find Kelvin. Celsius is 30 degree. Here you can say 30 degrees. So Celsius. So we will 30 degree plus 273. So the answer will be K will be equal to 303 Kelvin. Right? It will be equal to 303 Kelvin. Right? And now we have to find this pressure. Like here we are having pressure. We have to find this pressure in ATM because that's the standard, right? Here the pressure is given. P1 is equal to 820 and torr. We have to convert this into ATM. So let's convert it, right? Okay. We have to find in pressure 820 torr. We want ATM, right? So we will multiply this with ATM. And like here torr is there, so we have to cancel the torr. So one ATM is equal to 760 torr. We know this, that 1 ATM is equal to 760 torr, right? So here we will write 760 torr. Like it's necessary to write units, right? So here torr will be cancelled from torr, and now you can easily divide this and the answer will come, which is 1.07 atm. So this is the basic answer for the pressure. So now let's find the volume V2 by the help of ideal gas equation, right? So here we are having the equation, which is P1 V1 upon T1, right, is equal to P2 V2 upon T2. Let's arrange this by, like, first we do by CM, like we will do cross multiplication, right? So here T2 P1 V1 is equal to T1 P2 and V2, and we have to find V2, right? So V2 is equal to T2 P1 V1 upon T1 and P2. So this is the formula that will come, right? Now we will put the values, right? Let's put the values in this. So now you can see over here that it's V2. Now what's the T2? T2 was 273 Kelvin, right? Now what was the P1? P1 was 10. Okay, P1 was 1.07 atm, and the V1 was equal to 10.32 dm cube, right? And this we will divide with T1. T1 was equal to 303 Kelvin, multiplied by T1 was equal to, like, T1 is not P1, P2 was 1 atm. Now we have to do the calculation, right? So you can see Kelvin will cancel from Kelvin, atm from atm. Here only dm cube is remaining, and now if we will calculate it, we'll found that the value is equal to, the V2 is equal to 9.94 dm cube of N2O. N2O is basically laughing gas, right? So the answer we are having is V2 is equal to 9.94 dm cube of N2O. So I hope this word problem is clear to you, right? So now let's move to another word problem, which is related to basically to density, right? Let me first I'll give you the data, right? So that according to data, so here question number 2, right? So according to data, here D is equal to, like, we have to find the density, right? Now the temperature is given, which is 45 degree Celsius, right? The 45 degree Celsius is giving. Then we have given the pressure, which is P1, which is equal to 1.54 atm, right? Now we have to find the density basically. So you know what's the formula of this? So we have the ideal gas equation, which is equal to PV is equal to nRT. So by using that equation, we will find the density of this, right? So here we are having the equation, which is equal to PV is equal to nRT, right? Now we know that we have to just replace the number of moles from this equation, right? We know that number of moles is equal to, like here, number of moles is equal to given mass upon molecular mass and now this given mass is represented by small m, and this is represented by capital M, right? So we can easily replace this. Now it will be equal to PV is equal to M upon mRT, right? Now what will happen, that we know that the density is equal to mass per volume. Density is equal to, D is equal to mass per volume. So we can easily shift it, right? So what we will do, that we will shift this V with M. So in order to find the density, right? In order to find so what will happen over here, that P is equal to, here M will be shifted and M upon V R T will be there, and which is equal to density, right? So PM is equal to DRT basically. Now what will happen, we have to find the density, right? We have to find density over here. Now D is equal to PM upon RT. So you can easily put the values. Like how you will put the values, here you can see the temperature is given in Celsius, right? The temperature is given in Celsius. We will plus 273 into this, so it will come 318 Kelvin, right? The pressure is already in ATM. Now what you will do, you will just easily put these values. D is already equal to P, which is pressure, which is equal to 1.54 dm cube. 1.54 dm cube multiplied by given mass. Okay, here the gas oxygen was used, so you will write 32. R, which is 0.83. Here we will use the value which is in the STP, right? And the temperature, which is 300 Kelvin, right? You will see, okay, here we are having gram per mole, and there is a long unit of this. So by, if you will cancel it, you will get the density over here, which the unit of that density will be gram per dm cube, right? So I hope this word problem is clear to you.